What's going on, people? Get out of the way. You guys want a bite of Mrs. Phillips' apple treat? Too bad. None for you. All right. Temperature and energy. Heat and temperature. Heat is basically energy. Okay. And heat is energy. So more specifically, what kind of energy? It's infrared light energy. Okay. So there are many different kinds of light. Visible light is the one you're familiar with. Roy G. Biv. Infrared, ultraviolet, microwaves, radio waves, like cell phones use. X-rays, gamma. Okay, it's an electromagnetic spectrum. All light waves. The only ones we can see, of course, are the visible ones. Infrared is heat. How heat is transmitted. Heat is energy, which can be treated as a light wave. So anyway, infrared light energy. I'm reading the definition verbatim off my other screen. Infrared light energy is being transferred from a high temperature object to a low temperature object. So it gives you insight as far as the direction of heat, the direction that heat travels essentially is a lot of people always say or automatically say, oh, heat goes up. Not necessarily. Hot air or hot gases tend to go up because they're less dense, and colder, more dense gases sink. You get what's called convection. You'll learn that later. It gets transferred in the direction of colder substances or to colder objects or substances. So gradually over time it gets distributed. Okay, temperature. Temperature is, what's my exact definition? It's a measurement, okay, of the average, okay, kinetic energy of the individual particles that make up matter. And then I go on to talk about how average and total, why I put that in all caps. What's the big deal? Actually, it makes a massive deal. If temperature were a measure of the total kinetic energy of the individual particles that make up matter, it just wouldn't be possible. Our existence would not be possible. All right, kinetic energy is the energy of motion. So my hands have kinetic energy. My head has kinetic energy. Okay. Even the particles that make you up have kinetic energy because they're constantly moving and vibrating. All right, that's a major category of energy, kinetic energy. Potential is the other major category. We'll learn more about these later, but for now, you need to remember that kinetic energy is the energy of motion. So let's say this is a half liter, okay, just arbitrary. We have 6 molecules in it. Each molecule has 6 joules of kinetic energy. Remember, joules is a unit of energy, okay? So what is the average? The average KE is 6. All right, and then let's say that 6 more joules is added to the whole volume, and over time, those 6 joules gradually get distributed. Each molecule gets 1 more joule then. Each now has 7. Okay, they had 6 before, and they each got 1 more joule. So that makes each have 7. Do the molecules speed up or slow down? Well, they have more kinetic energy now. They now have more kinetic energy. And kinetic energy is the energy in motion. So if you have more motion energy, you're going to move more. What is the average kinetic energy of the molecules now? Well, if each of them have 7, there you go. The average is 7. Does the temperature go up or does it go down? All right. So what's going to happen when we add more heat to this container? It's not water. It's slurp. Have you ever had slurp, McGurk? Slurple burple. Slurp the burp. If you added more heat to half a liter of slurp, what would happen to the temperature? Of course, it's going to get hotter. The temperature is going to go up. Here I'm showing you why that is. All right. So if temperature is a measure of the average kinetic energy of the molecules that make up Schlurp, then if the average kinetic energy of those Schlurp molecules goes up, then the temperature will go up because the temperature is a measure of the average. Average. Almost out of time. Oh man, I'm almost out of time. You know what? I'm going to divide this up into 2 parts. Temp N. Oh my gosh. Screencastify.